Hi everybody. Today we are going to be covering lesson 5.17. So 5.17 is going to be talking about parallelograms and other types of quadrilaterals. So please make sure that you are doing the OMHS content. It gives good material to review and learn from, and also some really good practice problems. So let's get started. Okay. So let's talk about rhombi. Rhombi have the same properties of parallelograms. So all of the properties of parallelograms that we've already learned, those are all still fair game. And then we're going to add some new properties. So in addition to the properties of a parallelogram, which are listed for you here, we're also going to say that all four sides are congruent. Also in a rhombus, the diagonals are perpendicular. And we learned what perpendicular means. When they cross each other, they make a 90-degree angle. And the third property of a rhombus that makes it special is that its diagonals bisect opposite angles. So if I were to draw a picture of a rhombus, it would have all of the same properties of a parallelogram, so everything we've already talked about in a parallelogram, plus these extra three properties. So all four sides are congruent, so we can go ahead and mark all three sides congruent. Four sides, silly me. Diagonals are perpendicular, so here's a diagonal, here's a diagonal. They would make 90-degree angles. And it doesn't matter where I put that 90-degree angle. I could have put it here, here, or here. It would have been the same. And the diagonals bisect opposite angles. So each angle is being bisected, which means cut in half. Okay. So let's practice those properties with some examples. My first example says that JK equals 5. So JK equals 5. I'm going to mark that on the picture. JN equals 3. And MK is 8. So this entire thing is 8. We know that in a rhombus, all the sides are congruent. So JK is 5. All the other three sides have to be 5 also. We know that a rhombus is a parallelogram. Remember, in a parallelogram, diagonals bisect each other. So if this piece is 3, so is this one. And if MK is 8, that means that each of these pieces have to be the same size, making MK or MN 4 and NK 4, making the whole thing 8. So now we can just fill in the numbers. JM is 5. JL, well, that's the whole thing, 3 plus 3. MN is 4. And MK is 8. And they told us that here too. Looking at the second example, EF is 13. DF is 24. It's difficult for me to mark the whole thing 24. So because I know that the diagonal is bisected, I just go ahead and divide that by 2 right away so I can mark each piece. EH is 5. Okay. Well, again, diagonals bisect each other, so this piece has to be 5, and each side has to be congruent to the side that's given to me. So now we can fill in the missing things. GF is 13. HF is 12. GE is 10, right? Because here to here is 5 plus 5. Oh, that was GE. GH is 5. All right, I'd like you to try number 3. Put the given information in your picture Use what you know about parallelograms and what we just learned about rhombuses and see if you can figure out our 4 missing sides. Try that now. So you should have gotten VT equals 24, UV is 7, RS is 25, and ST is 25. Check your answers. Did you get the same answers I did? I hope so. If you didn't, double check my picture and see if maybe you made a mistake dividing or just a silly mistake that happens sometimes. Example 4, we're going to talk about angles. Okay, so in a rhombus, diagonals will always bisect each other, but they also are perpendicular. So that means that when they cross each other, they're making a 90-degree angle. So now I immediately know angle 8, which also tells me this angle, and this angle, they're all going to be 90. Another part of a rhombus is that the diagonals bisect opposite angles. So that means these angles are being cut in half. Okay, well, if this half is 38, then this half has to be the same. So now I know angle 3 is 38 degrees. I'm just going to go ahead and write 38 right there. Okay, now remember, a rhombus is a parallelogram. Parallelograms have opposite parallel sides. So this side is parallel to this one. And this would be my transversal. Remember, we learned in parallel lines that alternate interior angles are congruent. So the alternate interior angle to angle 3 is angle 5, which means angle 5 is also 38 degrees because alternate interior angles are congruent. And angle 4 now has to be 38 degrees also. So now I just need to find angles 1, 2, 6, and 7. So what I can do now is I can look at these as if they're triangles. So we know that angle 8 is 90. We know angle 5 is 38. Let's find angle 6. Do you see the triangle here? Okay, that was ugly. Let me try that again. Okay, so here we got a triangle. We know that the 3 angles in a triangle will always add up to 180. So 90 plus 38 plus angle 6, which we don't know, has to add up to 180. We can combine our like terms and subtract from 180, and we will get 52. So the measure of angle 6 is 52 degrees. Okay. Well, if the diagonals bisect opposite angles, that means angle 7 has to be the same size as angle 6. So that's also 52 degrees. And I know that alternate interior angles are also congruent. So angle 6 and angle 1 have to be congruent. So angle 1 is 52 degrees. And then this angle is being bisected. So that means angle 1 and angle 2 have to be congruent. So angle 2 is also 52 degrees. One way that students in the past have liked to think about a rhombus is they think about folding it. So I could take my rhombus and I could fold it and then fold it again, and I would have this little packet of triangles. All 4 of those triangles are exactly the same size. So if you can figure out 3 angles in one of the triangles, you'll know the 3 angles in all of the triangles. And that might be a helpful way to look at it. With our rhombi, we also have squares. And now a square is very special because a square has all of the properties of a parallelogram, all of the properties of a rectangle, and all of the properties of a rhombus at the same time. So those are listed here for you. Okay, so just to draw a picture, I can't put all of these properties in it. It would get awfully messy, but it would have all the properties of a rectangle, meaning it has 4 90-degree angles, and its diagonals are congruent. It has the properties of a rhombus, which say that all of its sides are congruent to one another. Its diagonals are perpendicular. And its diagonals bisect each other. See how messy this is getting already? But you get the idea. It has all of the properties of a rectangle and a rhombus, which means it also has all of the properties of a parallelogram. So let's practice using those properties to solve for our missing pieces. So if ABCD is a square and AD equals 4 root 2, let's go ahead and write 4 root 2 right there. And AC equals 8, so this whole thing equals 8. We'll find all of the missing information that we need. Okay, so it's a square. A square has all the properties of a rhombus, which means that all 4 sides are congruent. So this is 4 root 2, this is 4 root 2, and this is 4 root 2. It says that AC equals 8. So because it has the properties of a rectangle and a parallelogram, I know that the diagonals bisect each other. So AC has to be 4 here and a 4 here to bisect it. But because it's a rectangle, I know the diagonals are congruent. So this piece has to be 4 and so does this one. Okay, so let's deal with all these segments first and then we'll deal with the angles. BC is also 4 root 2. Noticing I'm putting 4 root 2. I am not putting this in a calculator and rounding to a decimal. Keep it 4 root 2. That's an exact answer. AC is 8. BD is also 8. And EC is 4. I'm going to erase my side lengths so we can talk about angles and not get just too messy here. Okay, so let's talk about angles. We know that a square has 4 right angles because it's a rectangle. And we know that its diagonals are perpendicular because it's also a rhombus. We also know that the diagonals bisect opposite angles. That's the property of the rhombus. So 90 divided by 2 is 45. So all of these little guys are 45. And each of these angles are 90. These say 45. My pen got a little squished there. DAB. Oh, well, that's that right 90-degree angle. It's a right angle. AEB. That's a right angle. CBD. That's this guy, 45. And BAC. Here we are, 45 degrees again. So even though none of the angles were actually given to me, because I know those properties of the rectangle and the rhombus, I was able to figure them all out. I'd like you to try number 7. TR is 2, PQ is 2 root 2, and you can use that information to fill in all of the other sides and pieces of diagonals, and then use what you know about a rectangle and a rhombus to fill in the missing angles. So try that now. Okay, so for PR, you should have 4. QS is 4. QT is 2, and PQ is 2 root 2. And then just going down the angles over here, you should have 45, 90, 90, and 45. If you got any of this wrong, go ahead and double check my picture here with yours. And also just make sure that you're reading those angles correctly. So angle PRS, I would put my pen or finger on P, and then trace to R, and then trace to S. And the angle that I'm forming there is 45. So just be very careful when naming those angles. Make sure you're looking in the right place. All right. The next example is giving us some vertices, and they want to know what kind of quadrilateral is this? Is this a parallelogram? Is it a rectangle? Is it a rhombus? Or is it a square? So now the thing about doing this is you have to kind of go through the process, because we know that we have these parallelograms, and then from a parallelogram we could have a rectangle, we could have a rhombus, and if they're both of those at the same time, then we have a square. So the first thing we need to do is check, is it a parallelogram? If it's a parallelogram, then we're going to check to see if it's a rectangle. Whether it's a rectangle or not, we're also going to check rhombus. And then if it's both of those, then we're going to say that it's a square. So let's do it. So a parallelogram. Remember, we have this awesome tool called the distance formula. The distance formula is not going away, and in fact, we're going to just keep using it over and over for many different ways. Okay, so parallelogram. How can the distance formula help me prove this is a parallelogram? Okay, we know that in a parallelogram, opposite sides are congruent. So if I can prove that opposite sides are congruent, then I can prove it's a parallelogram. So you could always graph this just to make sure, because if you have some vertical or horizontal sides, you can just count the blocks and you wouldn't need to use the distance formula. I don't think we have that here, but we can graph it also to see which sides are opposite what. So E is at -7, -4. F is at 2, -3. G is at 0, -7. And H is at -9, -8, all the way down here. All right. Not the prettiest graph, but it's all right. So by graphing this, I can also see which sides are opposite what. EF would have to be congruent to HG, and EH has to be congruent to FG. So we're going to find the length of all four sides. Yes, I know it's a little tedious, but at least it's not difficult, so that's good. So let's find EF and HG. So the square root, hopefully we're getting very good at this distance formula. We're going to use E and F. So we're going to subtract our X values, square them, plus subtract the Y values. Be careful with those negatives. -9 squared is 81. -1 squared is 1. It's the square root of 82. Let's find HG. 0 minus -9 squared. -7 minus -8 squared. Got an extra little negative in there. Oops. Okay. So 0 plus 9 is 9. 9 squared is 81. -7 plus 8 is 1. 1 squared is 1. So it's the square root of 82. Now, I know I didn't simplify these. It didn't ask me what the lengths were. I just want to prove that they're congruent. The square root of 82 and the square root of 82, those are congruent, so that's fine. So I can say that EF is congruent to HG. And now I have to prove the other set of sides are congruent. So we'll find EH and we'll find FG. So we'll use E and H. -7 minus -9 squared. -4 minus -8 squared. 2 squared is 4. 4 squared is 16. We get the square root of 20. Okay, so now let's find FG. 2 minus 0 squared. -3 minus -7 squared. 4 plus 16, square root 20. And you are welcome to use a calculator on these steps. Just make sure you're using those parentheses so those negatives don't mess you up. And yes, again, I did not simplify these, but it's not asking me for the length. I just want to prove that they're congruent. And negative or square root of 20 and square root of 20, those are the same. So I can say that EH is congruent to FG. And if it was asking me if this was a parallelogram, I would be done, because I've just proven the opposite sides are congruent, so it is a parallelogram. But we need to keep going, because we're not just checking, is it a parallelogram? I want to know if it's a rectangle, a rhombus, or a square. And now that it is a parallelogram, it's possible to be one of those other three. So let's test to see, is it a rectangle? So what property of a rectangle could I use the distance formula to prove? Well, we know that in a rectangle, the diagonals are congruent. So let's find the length of the diagonals. So in this case, the diagonal is EG and HF. So we're going to find the length of EG and we're going to find the length of HF. So EG will be the square root of -7 minus 0 squared, -4 minus -7 squared. I ran out of space. So this becomes 49 plus 9. So I get the square root of 58. And now we'll find FH. So using the points F and H. 2 minus -9 squared, -3 minus -8 squared. Let's see here, this is 11 squared, 121. This is -3 plus 8, 5 squared is 25. So the length of FH is 146, or square root of 146. Well, that's not equal to that. So this is not a rectangle. Cool. Well, let's see. Is it a rhombus? To test if it's a rhombus, we would want all 4 sides to be congruent. But all 4 sides were not congruent. Looking back at our work for parallelogram, 2 of the sides were the square root of 82 and 2 of the sides were the square root of 20. Those aren't congruent, all 4 of them. So it's not a rhombus because it doesn't have 4 congruent sides. So because it's not a rhombus, it can't be a square. And we just proved that the diagonals were not congruent, so it can't be a rectangle. So the best classification for this shape is a parallelogram. All right, let's practice this one. Okay. The first thing we want to do is we want to know, is it a parallelogram? If it is a parallelogram, then we can test the other ones. If it's not a parallelogram, then we just stop and we say it's none of them. Okay, so let's see, is it a parallelogram? Let's sketch this thing. Whoa. So 5, -3, 7, 1, 9, -3, and 7, -7. Okay, so I've got this guy going on. All right, so let's test if it's a parallelogram. My opposite sides are LK and NM, so we'll test those. And then we'll test LM and KN. And we're going to use the distance formula each time. So go ahead, use the distance formula for each one and find the length. Do that now. So you should have gotten the square root of 20 for each one. And if you simplified that, you would have 2 root 5. And it's okay if you simplified it to 2 root 5. But in any case, we just proved that the opposite sides were congruent. So we just proved that LK was congruent to NM, and we proved that LM was congruent to KN. So that proves it's a parallelogram. So check, it's a parallelogram. Then we would test, is it a rectangle? Okay. So a rectangle has 90-degree angles, so we could find the slopes and see if they're perpendicular. Or my favorite way is to see, are the diagonals congruent? So the diagonals here are LN and KM. And if you graphed this nicer than I did, you recognize that you have a horizontal and vertical diagonals. So you could just count the blocks, or if you didn't graph it pretty and you want to use the distance formula, you are welcome to do that also. But if you count the blocks for LN, you would get 8. Or if you used the distance formula, you'd get like the square root of 64 and still get 8. And for km, you would get 4. So you could just count the blocks or use the distance formula. My diagonals are not congruent, so this is not a rectangle. So now we need to ask ourselves, is it a rhombus? Okay. Properties of a rhombus say that your diagonals are perpendicular and the sides are all congruent. Notice that our sides were all the same. So because the sides are all congruent, we can say that it is a rhombus. Or, like we said, the diagonals were a horizontal and vertical line here. Horizontal and vertical lines are always perpendicular to one another. So you could also say that the diagonals are perpendicular. Both would be correct. So not only is this a parallelogram, it's a rhombus. So its most specific classification is rhombus. I can't say square. If I was going to say square, it would have to be a rhombus and a rectangle. And because it was not a rectangle, it cannot be a square. So this is a rhombus. At the end of these notes, I provided you with this little chart. I think it can be very helpful when studying. You have parallelograms and all of the properties of them. And then from parallelograms, you could have a subset of rhombuses or rhombi, and there's their properties. Or you could have a subset of rectangles. And if you have both rhombi and rectangle, it's a square. Okay? So all rhombuses are parallelograms. All rectangles are parallelograms, but not the other way around. I cannot say that all parallelograms are rhombi, and I cannot say all parallelograms are rectangles. So this only works going down, but not going back up. All squares are rhombuses, all squares are rectangles, all squares are parallelograms. So I could even make this a Venn diagram if I wanted to. So I could say if it's a rhombus, then it's a parallelogram. If it's a rectangle, then it's a parallelogram. If it's a square, then it's a rhombus. If it's a square, it's a rectangle. Hopefully these properties help you when studying and practicing. Today's attendance word is both. Okay, squares have properties of both rectangles and rhombi, both. Don't forget to do that attendance quiz. It will close at noon on Wednesday. Have a great day, everybody.